And there comes our old and haunting Heisenberg. If the position of electron is measured with an accuracy of plus minus 0.002 nanometer, right? So I'm given delta x is 0.002 nanometers. Calculate the uncertainty in the momentum of electron. Now delta p is question mark. Suppose the momentum of electron is h by 4 pi into 0.05 nanometers. Is there any problem in defining this value? You remember Heisenberg's principle? Yes. From there we have a formula. What is that? Uncertainty into momentum into uncertainty in position is greater than or equal to h cut by 2. And h cut is how much? This is h by 4 pi. In limiting case, it may be equal to h by 4 pi. Right? Right. All we need to do is to just substitute. I'm given delta p, the uncertainty in position, your delta x. I'm supposed to find delta p, right? So delta p into 0.002 nanometers is so much. In the limiting case, we just use equality. So delta p is greater than or equal to h 6.626 into 10 is minus 34 joule second divided by 4 into 3.142 into 0.002 nanometer, which is so many meters. So good looking it is. How much will this boil down to? You can calculate that. This would give you 2.637 into 10 is minus 23 kilograms meters per second. SI units of momentum, 2.637 into 10 is to minus 23 kg meters per second. This is the uncertainty in momentum. Okay, this is fun answer. Now comes the second part. Suppose the momentum of electron is h by 4 pi into 0.05 nanometer. Please look at the units. Units of momentum is not nanometer. So actually this is, they are saying P is h by 4 pi into, this should be in denominator, 0.05 nanometer. This is what they are saying. It appears as if this is separate and this is separate. No. Assume this in denominator. Then it would work. Say P is so much, right? Is there any problem in defining this value? They are asking. We have found uncertainty in momentum. They are saying this is uncertainty, fine. But what is the momentum? Momentum is so much. Delta P we just found is h by 4 pi into 1 upon 0.005 nanometer it was. Right? No, 0.002 nanometer. Okay. Can I take a ratio? I very well can. If I take a ratio, P by delta P, this comes out to be how much? This comes out to be 0.05, 0.002. So delta P by P is 25. What does that mean? It means that if momentum has certain value, uncertainty is 25 times the momentum itself. That sounds very stupid. Say my height is, say, around 5 feet, 5.5 feet, 6 feet, say, for example. It's not 6 feet, less, but assume. Now I say my height is 6 feet. Somebody is trying to measure, and he says that your height is not 6 feet. It could be, he could be measuring anywhere between 6 feet to 150 feet. 150 feet is taller than the building itself. It's too much. I mean, so many stories, 15-storied building. I'm of course not as tall as 15-story building, god damn it. But if that is the kind of uncertainty which somebody is saying, that momentum may have a certain value, but the uncertainty, the error in the momentum may be 25 times the actual value, the correct value. That means that calculation is absurd. That measurement is very stupid, very, very inaccurate. So when they are saying, is there any problem in defining this value? There is a problem. You have tried to make the position so accurate. The problem is the uncertainty in momentum has become absurdly large. So actually trying to measure momentum is meaningless. That is the problem associated with this measurement.